We have here a new problem involving hydrostatic force acting on submerged surfaces. Determine the force pushing on the stopper at the bottom of a circular gate due to the hydrostatic force of the water acting on the gate. We have here a circular gate 1.2 meter in diameter, hinged at the top and supported by a stopper at the bottom. The top is 2.6 meter below the water surface. In solving problems involving hydrostatic forces, we will normally start by showing the pressure diagram. And if the liquid surface is exposed, the pressure gauge there is 0 and it will increase with depth and it is linear. We know the formula of pressure as the unit weight of liquid times its depth. Pressure increases with depth. Now, we are only interested with the pressures acting on the gate, so we can neglect the top part here. Now, we can get the resultant of all this pressure into one single force, which we call the hydrostatic force, and this always acts at the center of pressure. The center of pressure is right below the center of gravity or the centroid of the submerged surface, and the distance between them is called E or eccentricity. The distance between the center of gravity or centroid of the surface to the liquid surface vertically is called h bar or the average height, which is equal to 3.2 meter. And we know that because we know that this distance is 0.6 or half of the diameter of the circular gate. In order for us to solve the reaction at the stopper, we need to calculate the hydrostatic force F and the value of the eccentricity E. Let's begin with the hydrostatic force F. The hydrostatic force is a force, and the formula of a force is the pressure times the area to which this pressure is acting. However, we can see here that the pressure is not uniform. So, we need to get the average pressure. To get the average pressure, we remember that the formula for pressure is the unit weight or gamma of the liquid times its depth or H. So, we can get the average depth because gamma is constant, depth is not constant, and we can multiply it by the area A. And the average depth is called the H bar. So the final formula for the hydrostatic force is gamma, unit weight of the liquid, H bar, the average depth, times A or area. H bar being the distance from the center of gravity to the water surface. We can substitute the value given. Unit weight, since this is water, is 9.81. H bar is 3.2 meter. Area is pi over 4 times 1.2 diameter is squared for circle. And the value is 35.50 kilonewton. Next, we can calculate the value of the eccentricity E. And the formula is E is equal to moment of inertia I along x-axis all over A area times y. The moment of inertia of common shapes are this. And since we are dealing here with a circular gate, so the moment of inertia is pi d raised to 4 all over 60. And the value of y is the distance from the center of gravity to the water surface, but it should follow the angle of inclination of the surface being considered. If the surface is vertical, just like in our figure here, the value of y is just the same as the value of h bar, 3.2 meter. So we can now calculate. We know that the I or moment of inertia is pi over 64, diameter 1.2 raised to 4, all over pi over 4 times diameter is squared, that's the area, times 3.2, the value of y. We can calculate 0.28 meter. Since we now have the value of the eccentricity and the hydrostatic force, we can now calculate the reaction acting at the stopper. In order to do that, let us isolate the gate and free body diagram. We have a force acting on the stopper, which is found at a distance 1.2 meter from the hinge. On the other side is the hydrostatic force, and at a distance of 0.6 plus eccentricity. From here, we can take summation moment at the hinge, and we know that to be 0. And we will consider clockwise moments as positive. Force acting on the stopper times 1.2, since it's clockwise, it's positive. And negative hydrostatic force times moment arm 0.6 plus E is equal to 0. We can substitute the values of the hydrostatic force and eccentricity, and the value of the force acting on the stopper is 18.58 kilonewton. Thank you very much. Follow for more and visit my channel. See you.